Welcome to this week's midweek Space Startup News. And as usual, I'll be going over a number of space news articles I found on websites, blogs, or social media posts. So first of all, let's bring up this banner. We're on X at Space Startup Hub, so you can follow us there. I post links to my YouTube videos on X and occasionally some other stuff as well. So let's get into the first article this week. If you're not aware, the 41st Space Symposium is taking place at the moment. Many companies from space industry, the large players and the space startups and agencies will all be at this conference. You can see some images here. Where commercial space meets, 247 exhibitors, 24 space agencies, and 1,500 plus organizations. And that's from the previous one, so we'll see how many turn up for this one. So that's the Space Symposium, but already we're getting some information from a number of these space startups who are exhibiting at this symposium. So let's get into the first social media post, and this is Astrolab. So they say, hello Space Symposium, Astrolab is here this week alongside many of our partners and collaborators. Come by the Astrolab and HPE booth. Our human in the loop mock-up of our Flex lunar rover used for NASA testing. This is the large rover for crewed transportation on the surface of the moon. Our Flex Lunar Innovation Platform, FLIP, that's a smaller rover that's robotic and it's for tech demonstrators and scientific payloads. The rover that is heading to the moon in the second half of 2026. Now, this is the rover that includes Interlune's tech demonstrator, which is a multispectral camera that will help identify helium-3 deposits. So that ties into the video I did earlier this week. Axiom Space's AXEMU spacesuit. Mock-ups of strategic partner Venturi's tires and batteries, which will be used on both Flip and Flex. So that's the special tires on the moon rover. The wheels have to be deformable so they don't jolt the astronauts too much with all the bumps. And they also have some images which we'll look at now. So this is one of the images, and you can see the AXEMU spacesuit there. That's a critical piece of technology for the Artemis program. This is the only suit that's been developed for astronauts to walk on the moon, so it has to work. Obviously a fake Flex rover, that is not what it looks like. It doesn't seem very sturdy at all. And then we have another image of the spacesuit. So this is what the Flex rover actually looks like. This is real hardware, and you can see there's two astronauts at the back. So this will be a workhorse on the lunar surface. It looks, from what NASA is saying, the lunar terrain vehicles will be heavily used for base preparation, site preparation, for leveling the ground, removing rocks and debris, putting down scientific payloads, and so on. So they will be in very high demand by the looks of it. So anyway, that is the first story from Astrolab. Okay, on to our second story, and this is from Vast Space, and they've unveiled their astronaut flight suit, built with a human-centric design and developed in partnership with Vast lead astronaut Astro Fustel. The suit prioritizes mobility, comfort, and on-orbit functionality. And there's a video, so let's have a look at that. Let's play that now. So this is for use inside the Vast Space Station. So it's got plenty of pockets and zippers, and hopefully it's comfortable to wear. Ventilation, important. They have Velcro straps as well. Pockets for utility. This is Vast One, a small prototype commercial space station. It's only about 45 cubic meters. There you go. Let's have a look at a render of the Vast Space Station. There's Crew Dragon docking with it. And this can support crew for up to 4 weeks, I believe. So fairly short stay missions for private astronauts or potentially NASA or ESA or other space agencies. There's 10 payload slots, so you can do science, you can do tech demonstrations, the sleeping quarters there, and storage space. So this should be launching in 2027, which is only next year. It was supposed to launch this year, but there's been some delays. It's well into qualification testing now. The flight hardware's built, they just need to qualify and test it. So hopefully it will launch next year. So anyway, that is a render. This is one of the replies for the flight suit, which I don't know if people get that reference. But anyway, that is Vast Space. Okay, on to our next story, and this is on Firefly Aerospace and Northrop Grumman, which are working on the Eclipse MLV, or medium launch vehicle. So the Expo says Eclipse is getting a fresh look. Firefly and Northrop Grumman are redefining what's possible in medium lift launch, and this game-changing rocket deserves a livery that matches. Learn more about Eclipse here, and it includes a video, so let's just watch the video now. There it is. There is Eclipse, launching from Wallops, I believe. Northrop Grumman and the Firefly logo. That's about it, I think. Yeah, that's all we have, but you can see it's a new render of the Eclipse vehicle, which should be launching, well, in theory, it should be launching later this year. There's been no update on the website to say any different, so it's 2026. So we do have some hardware. This is the, I think, the interstage for the Eclipse vehicle. So you can see the crew there, and there's the hardware. And we do have the specs for Eclipse. So it's 16 tons to low Earth orbit, over 2 tons to translunar injection, so it can push over 2 tons towards the moon, 7 Miranda engines, and 1 vacuum optimized engine called Vera, and ISP is 328 seconds. So I do also have this graphic. This graphic is a bit old, so Blue Origin's launched more than that, but it gives you an idea of payload to orbit. So Firefly Aerospace and Northrop Grumman at the bottom with Eclipse is 16 tons. It's not approved for national security launches yet, but you have to fly a few times before you can get qualified. So at the moment, it isn't. Terran R is over 23 tons. Stoke Space is actually less than that. I say 10 tons, but I think it's between 3 to 7 tons, depending on whether it's expendable mode or not. Rocket Lab is 13 tons. ULA Vulcan Centaur is 10 tons, but I think it's more with the boosters. And Blue Origin is 45 tons, but with their new configuration, their 9x4 configuration, I think it's up to 70 tons. They have this super heavy configuration. So Firefly Aerospace is 16 tons, perfectly fine. You can put a lot of mass to orbit. You can do constellations. You can do cargo resupply missions. So Northrop Grumman manufactures the Cygnus vehicle, which supplies the International Space Station with cargo. So with this new vehicle, I expect Cygnus will fly on Eclipse rather than the Antares vehicle, which uses Russian rockets. That is the plan, I think. We'll see whether it launches later this year. So let's move on to the next story. Our next story is on a post by Blue Origin. So they say, melt, extract, breathe, repeat. From moon dust to fresh air, our Air Pioneer technology turns lunar regolith, that is lunar soil, into breathable oxygen, ready for astronauts returning to the moon. At our Space Resources Center of Excellence in LA, we developed a reactor that melts regolith simulant and passes a current through it to release oxygen and other gases. The gases flow into the purification system. A flight-qualified Air Pioneer at this same scale could provide the first breath of life for a sustainable moon base. Let's have a look at the image. So we can see on the left is the reactor that melts the lunar regolith or the lunar soil. And on the right, we have the purifier that separates out from all the gases, separates out the oxygen and purifies it for breathable air or to capture it and liquefy it for use as a propellant. So the Blue Origin Mark II crewed lunar lander is reusable, and the propellant is liquid hydrogen and liquid oxygen. So this system could produce the oxidizer to refuel the Mark II lunar lander, and that way it can be used many times. You'd also have to separate and liquefy the hydrogen, which is more difficult because the boiling temperature's a lot lower. But I'm sure Blue Origin is also working on that. And once they've got the oxygen and the hydrogen stored in liquid form, cryogenically, they can refuel their lunar lander and fly as many times as they want. So they have a whole team at Blue Origin working on this. And the team's called Blue Alchemist, and there they are. And they're not just working on volatiles such as oxygen, they're also producing metals. There's a whole series of metals like silicon and ceramics they can produce. So between oxygen and hydrogen, you potentially produce silicon for glass or for silicon wafers, and also aluminium for construction, and potentially other metals, materials, and ceramics. So that's all very interesting. And we have a look at Blue Origin Mark I. This is not refuelable. You can see Jeff Bezos on the left at the bottom there to give you an idea of the scale. And this is a smaller vehicle. This is the Mark I. The Mark II is much bigger. So this is due to fly to the moon this year. So I think it's getting quite close now to launching. And Blue Origin is working on an upgrade to the New Glenn vehicle. This is a new upgraded vehicle with 9 engines on the first stage instead of 7. And the second stage has double the engines. It goes from 2 engines to 4 engines. So this is the 9x4 configuration. And if you look at mass to orbit, you can see that with the new super heavy New Glenn, it can lift 70 metric tons to low Earth orbit, 14 tons to geostationary orbit or geosynchronous orbit, and 20 tons to translunar injection, which means I think it's powerful enough to send the Orion capsule towards the moon. They're making a lot of progress with the rockets, with the landers, and with the in situ resource utilization technology, as we've just seen with this Air Pioneer system. So let's move on to our final story this week. Okay, and our final story is on an interview with Jared Isaacman at the Space Symposium. So let's just have a look at this article. I marked up a few sections. So it's NASA Administrator Jared Isaacman on Artemis budget and establishing a lasting space vision. So I'm more interested in this section down here. So he was asked about Artemis 2, setting up the lunar vision you put forth at ignition. That's the event where there was a pivot from NASA towards a surface base on the moon, cancelling or pausing the Gateway Station and focusing entirely on the Artemis base camp and lunar operations, lunar surface operations. So he said, no one at NASA that I've spoken to at any level of the organization thought it was a good idea to fly Artemis 2 and wait 3 years to try and attempt a moon landing. No one thought that was a good idea. He then goes on to say, when I got there, we were going to buy one extremely expensive lunar rover. If we're going to build a base, we need dozens of rovers. What were we thinking? We're making it super hard on industry with these bespoke commercial lunar payload services missions, 2 or 3 a year. No wonder our batting average isn't good. I want to unpack what he said there because we know there's a pivot on the LTVs, the lunar terrain vehicles. NASA was only going to pick one of those vehicles. The options are Astrolab's Flex rover, the Intuitive Machines Moonracer, and Lunar Outpost Eagle LTV. NASA has decided that they need lots of rovers for site preparation and so on, base preparation. So instead of having one extremely expensive, according to Jared Isaacman, rover, they will go with less capable rovers to begin with that do the basics of what they need and have more of those rovers and potentially on-ramp other providers. So they have 4 or 5 or 6 different companies providing rovers because they think they're going to need like 12 or at least a substantial number of rovers. And so the way they've done that is by descoping what's needed. You don't need a robotic arm to begin with. You don't need it to last over the lunar night to begin with. Eventually you get those capabilities in like phase 3. So let's carry on with what he was saying. And then he goes on to say, no wonder our batting average isn't good. So for Eclipse missions, it's 1 out of 4. Blue Origin was the only 100% successful mission. I would argue Intuitive Machines Mission 1 was quite successful. It did topple over. A lot of the payloads were able to function and transmit data to NASA. So I'd say that's 50% successful. Intuitive Machines Mission 2 was a complete failure, I think. Astrobotics Peregrine lunar lander failed around Earth and plunged back into the Earth's atmosphere. So that was a complete failure. It's not good, the average at the moment, but hopefully that will change in the future. Then he was asked the question, have any arguments from CLD companies, that's commercial LEO destinations, that is commercial space station companies, swayed you on proposed changes to that program? And he responds, I'm not surprised the CLD providers don't like what we had to say, so prove that we got it wrong. So the CLD providers are Starlab, Axiom Space, Vast Space, and potentially Orbital Reef, although I think that's on the back burner, to be honest. He goes on to say, I directly paid for 2 human spaceflight missions. That's not going to a station, that's just paying to get there to space. It's extremely expensive, and there isn't a long list of people waiting. He goes on to say, prove we have it wrong, that is, prove NASA is wrong in their evaluation that there's no viable commercial market for space stations. That is NASA's considered opinion, as they stated in the Ignition event. So I will eventually do a video on the commercial space station pivot from NASA. But the bottom line is NASA doesn't think there is a viable commercial market for space stations at the moment. I can tell you that if somebody wants to sign up today for the next private astronaut mission, there's a seat available. That doesn't support a robust demand signal in my mind, but I hope we have it wrong. Then asked about how do you politics-proof your moon plans, and he says administrations past have thought the right approach was to make a program that is too big to fail. What they didn't realize is that you can also make it too big to succeed. This is the right approach. Phase 1, Phase 2, Phase 3. If the next administration wants to dial back a little bit of moon-based spending, no problem. That is the article on an interview with Jared Isaacman on his thoughts on the commercial space station pivot. My next video will be on potentially a pivot from Europe. Gateways also been paused or cancelled. Europe had a lot of hardware it was building for the Gateway. They spent a lot of money, many hundreds of millions of euros on Gateway. They spent hundreds of millions of billions on European Service Module. And we just saw 4 North American astronauts go around the moon, which a substantial amount of money needed for that was paid for by European taxpayers. Europe has no seats on Gateway because it's going away. They have no seats to the surface of the moon, and they're paying absolute fortune. So the question is this NASA Artemis plan the best approach for Europe and for European taxpayers? Perhaps Europe could pivot towards a European-led space station. We've just heard from Jared Isaacman there's no commercial viable market. Europe or ESA could support a space station for European science, European hardware, European launchers, and so on. And that would seem a better use of European taxpayer money than sending North American astronauts around the moon and to build a moon base. So anyway, that is my next video, and that should be out on Friday. So thank you for watching Space News, and I will see you next time.